Hello everybody, this is the last video clip for the chapter 6, okay, and we still in 6.3, which is the continuation of the L'Hopital's rule. So don't forget that the L'Hopital's rule actually is the consequence of the Cauchy mean value theorem, and the Cauchy mean value theorem saying that roughly speaking, your f at alpha minus f at beta over g at alpha minus g at beta equals to f prime at u over g prime at u. Okay, roughly speaking, you are going to have this equation. However, we have like some condition that your f must be continuous in the closed interval and differentiable in the open interval and that kind of thing. Okay, so today what we are going to do is to look at another kind of L'Hopital's rule. Okay, previously what we have is that we got the rule that take care of the 0 over 0 condition, okay, I mean situation, and today we are going to consider the some kind of something over infinity condition. Okay, actually in math 1, what you do is you considering the situation of like infinity over infinity. However, what we are going to prove is a little bit more general, okay, so that we just look at the bottom that it is goes to infinity. Okay, so we are going to let your a and your b and you allow your a to be a negative infinity, allow your b to be infinity, and your f and g are differentiable on this open interval a b. Your g prime is not 0 for each and every x inside this interval, and assume that, as I told you, the limit of your g as your x goes to a from the right equals to either positive infinity or negative infinity. Okay, however, what we are going to do, okay, for this video clip, it is fix your g to goes to infinity. Okay, if your f prime over g prime, the limit as your x goes to a from the right equals to L. Okay, this L can be a real number or can also be negative or positive infinity. Then your quotient fx over gx at your x, as your x goes to a from the right, also equals to that value L. Okay, so what we are going to prove today is only for the case that your L is a real number. Okay, and then the rest that will be a little bit tedious. Okay, and you may not need to know the proof. Okay, this one is just like for you to see like how we think. Okay, how we think and how we apply something that we have in hand. Okay, in order to get what we need. All right, so let us try to do the proof. Okay, so as we told you that we are going to assume that the limit as your x goes to a from the right of your f prime and g prime equals to a real number L. Okay, and we need to prove this limit, right? So it means that we are going to let any epsilon positive given, and we are going to find the c such that fx over gx minus L will be less than this epsilon whenever your x inside the open interval from a to c. Remember the limit as your x goes to a from the right. Okay, however, before we go to that, by this epsilon and by this limit, you can first find the c, okay, which is greater than a, such that for each and every x inside this interval from a to c, your f prime x over g prime x minus L will be less than epsilon. Okay, and you may see immediately that here is the link between, you know, the f prime and g prime with just f and g itself, you see. So later on we are going to use that Cauchy mean value theorem. Okay, however, let us like do it this way first. Okay, and maybe epsilon is too what should I say is too um, fictitious. Okay, so to be more realistic, we are going to compare this one with 2 epsilon over 9. You are going to know why we need this value later on. Okay, this one is like something that you are going to connect the pieces together. Okay, so this one we are going to keep this in mind first. However, because your limit as your x go to a from the right of your gx equals to positive infinity, okay, we may be saying that with this epsilon, okay, you can find another c hat, let's say, greater than a, such that your gx it is greater than instead of using epsilon, okay, greater than 1 over epsilon for each and every x again inside this interval, okay, on the right of your a. So what does this mean? It means that if you do the reciprocal, okay, 1 over gx and then minus 0, it will be less than, right? Okay, from this inequality, it will be less than a reciprocal of 1 over epsilon, which is epsilon, for each and every x inside this interval from the right of your a. So it means that the limit of your 1 over gx, okay, it is 0 as your x goes to a from the right. I mean, this one is makes sense, right? Because your g is getting larger and larger, so a reciprocal of a large number, a huge number, will be a small number. Okay, so what does this mean? So it means that if you look at a limit as your x goes to a from the right of this function fy over gx, okay, your y is fixed to be 1 point, okay, it will be 0, and the limit as your x go to a from the right of your gy again, okay, your y is a fixed number because right now the thing that moving is only the x. This one will goes to 0 as well, okay, for each and every y inside this interval from a to c, right? Just one number. So what does this mean with this epsilon again? I'm sorry, with this epsilon again, okay, we can say that there exists a c tilde, okay, which is greater than a, such that your absolute value of fy gx actually subtracted by 0, okay, this one will be less than epsilon, and the L with dy over gx, okay, this one will be less than epsilon, as well as your gy over gx itself, okay, this one will be less than epsilon. Okay, however, I mean, again, that epsilon, okay, it is too fictitious, so to be realistic, okay, you are going to divide by 3. Later on you know why we need to divide by 3, and instead of epsilon, actually we are going to fix your epsilon to be 1/2 for this gy over g of x, okay. So this one, the inequality happen for all x within the a to c tilde. Okay, now we are ready to use to combine these pieces that we prepare with the f prime over g prime here. Okay, so since your f and g are differentiable over the interval from a to b, okay, by the Cauchy mean value theorem, okay, you can find the point u, okay, inside the open interval xy, which is a subset of a to c, such that this quotient f of x minus f of y over g of x minus g of y equals to f prime u over g prime u. Okay, So this one you keep it in mind first, okay. And we know that I mean what we really need is to evaluate the limit of f over g, right? So we are going to try to change this one, okay, this quotient into the f over g form, okay. So to do that, so this one actually is not from here, but just considering only this part, okay, only this part, you know that your fx minus fy over gx minus gy, it is the same as fx over gx, fy over gy, over gx over 1 minus gy over gx. So basically you just multiply the top by 1 over gx and the bottom by 1 over gx, okay. And we can do this because we know that as your x goes to a from the right, your gx is positive. So actually your gx your gx goes to positive infinity, right? So your gx always positive, is it? So you can just do a reciprocal and you don't care about your g will be 0, okay. And right here is the portion that you need, right? Your fx over gx, okay. So you are going to connect the dot, okay, by this one actually equals to this quotient, right? So you are going to solve for this red box, okay, by multiply this one up and add this one to the other side, okay. So it means that your f of x over g of x will be equals to f prime u over g prime u 1 minus gy over gx, and then add your fy over gx. So you may see now that, hey, this is something that you have here, right? You see all the quotient that you got, okay, except, okay, maybe this one is something that's still in mysterious, okay. What we are going to prove, that the limit of this quotient equals to L. So you need to compare this one with L, right? So you are going to actually subtract L both sides, okay. However, if you just keep it like that, that will be a little bit more difficult because what you have is the difference between the L and F prime and G prime, right? So it means that you need to really combine the L with F prime and G prime, okay. So how are we going to do that? You see that your F prime and G prime, it is attached with this one. So what we do is to like add this L gy over gx and subtract this L gy over gx. So you see this quotient, it is this one that you prepare, okay. So after you do this kind of addition, you know that this one together, okay, you get this factor, right? You get this factor. So you are going to have your so it means that your f of x over g of x minus L equals to f prime u g prime u minus L multiplied by 1 minus gy over gx, okay, and then subtract this one, the leftover, okay, gy over gx and your fy over gx, right? So as you have the absolute value, okay, you can use the triangle inequality to compare this one with the absolute value of f prime u g prime u minus L, okay, and 1 plus the absolute value of gy over gx and L gy over gx together with fy over gx. Okay, so right now you know that this first one, okay, what is it that you already have here? You saying that this difference between f prime and g prime with L, okay, less than 2 epsilon over 9. So this one will be 2 epsilon over 9. This one will be 1 plus, what is a gx over gy? Right here, it is 1/2, okay? So it is 1 plus 1/2. The L with gy over gx, okay, it is compared with epsilon over 3. And your fy over gx, it is also compared with epsilon over 3. Okay, so this one, it becomes 3 over 2, which will cancel with this 2 here, and the 3 will cancel with the 9. So you have epsilon over 3 3 times, so you got the epsilon at the end. All right, so this means that the difference between the quotient of f and g minus L will be less than this epsilon given, okay, for each and every x inside this interval from a to the c tilde, right? So you have that the limit as your x goes to a from the right of fx over gx, it must be L. Okay. Okay. So now let us considering what we have it here, okay, as the example. All right, so here for the first one, your g is the x, and the limit as your x goes to infinity of the x infinity. Okay, so as I told you that even though in the proof of our theorem we prove only the one with x goes to a from the right, okay, however your a can be positive infinity, negative infinity, can be anything. Okay, so this one we are going to apply with the positive infinity here. Okay, and the limit as x goes to infinity of g prime, it is the limit as x goes to infinity of 1, which is 1, and it is not equals to 0, okay, for every x in the real number. Okay, so we know that from the and another thing that we need to know is that the limit of your f prime over g prime, it is the same as 1 over x over 1, okay, which is like 1 over infinity, so it goes to 0, and it is a real number. So by the L'Hopital's rule, okay, and the second one, okay, we know that this limit of the quotient fx over gx, or the limit of log of x over x, it will be also 0. Okay, okay, and some example may have the first setting is not in terms of fractions, however it still can looking at it as a fraction as well. For example, this one can be regarded as x squared and over e to the x, right? And again, the limit as your x goes to infinity of gx, it is the limit of the e to the x, which is infinity. So we can, and the limit as your x goes to infinity of g prime, it is the limit as your x goes to infinity of e to the x again, okay, which is infinity, so of course it is not equals to 0, okay, as your x goes to infinity. All right, so it means that you may be able to apply the L'Hopital's rule. All right, however, as you apply the L'Hopital's rule once, okay? So this one is like you have the scratch paper first, that your f prime and your g prime look like this. You still cannot do it, right? Okay, so you may need to apply the L'Hopital's rule twice, okay? So what you know is that the limit as your x goes to infinity of 2 over e to the x. What is the 2? The 2 is the second derivative of your f, right? So this one goes to 0. So you can immediately conclude that the limit of 2x over e to the x, it is 0, right? And the limit as your x goes to infinity of x squared over e to the x, it will also be 0. So this one, it is actually f double prime over g double prime. This one, it is actually f prime over g prime. And this one, it is go back to f of x over g of x. Okay. And you may look at this one, okay? On number 3, we need to evaluate the limit as your x goes to 0 on the right of x and log of x, okay? So this one at the beginning doesn't look like fractions, right? So you may need to rewrite it in terms of fraction, which will be log of x over 1 over x. This one will be your gx, right? So as you look at it, this one, which is the limit of your gx, it is infinity, right? And the limit as your x goes to positive infinity of your g prime, okay, it will be negative 1 over x squared, which is negative infinity. So it's not going to be 0, okay, for your x in real number, right? So it means that you can apply your, oh, and by the way, you need one more condition, that the limit as your x goes to positive infinity of your f prime, okay, this one is your f, so your f prime, it is 1 over x, your g prime, it is 1 over x squared. You rewrite it a little bit, okay, it will be negative x, which is 0. It is a real number, so it means that this limit, okay, of your log of x over 1 over x can be calculated by the limit of f prime over g prime, which is 0, okay? So it means that what you need at the beginning, which is in terms of multiply, x multiplied with log of x, it also equals to 0, okay? Okay. And the next problem will be the problem that pretty classical, okay? The thing that you need is to evaluate the limit as your x goes to 0 from the right of 1 plus 1 over x raised to power x, okay? Providing that you should know that 1 plus 1 over x raised to power x actually equals to e and then x log of 1 plus 1 over x, okay? And we are going to use the fact that this exponential is actually continuous function, okay? And by continuous, okay, we are going to pass the limit, okay, we are going to pass the limit into the limit of the exponent, okay? And then the limit of this exponential, it will be e raised to power the limit of the exponent. So what we concentrate, okay, we are going to concentrate on this limit as your x goes to 0 from the right of x and log of 1 plus 1 over x. Okay, again this one it is not in terms of fraction, so you are going to rewrite your f like that over your g like 1 over x. Okay, so you use the same argument over here that the limit of your g it is infinity, and the limit of g prime it is not 0. However, another argument that you need is that what is the limit of your f prime over g prime. Your f prime will be 1 over 1 plus 1 over x, and a derivative of the inside using the chain rule, and this one a derivative of 1 over x it is negative 1 over x squared. So actually these two terms cancelled, and the limit go directly to this 1 over x, which is 0, so you got 1. So it means that by the continuity of the exponential, okay, we know that this limit, let me just write down here, we know that the limit as your x goes to 0 from the right of 1 plus 1 over x raised to power x equals to the limit of e raised to power x log 1 plus 1 over x, and it is the same as e limit as your x goes to 0 of x log of 1 plus 1 over x. Okay, and this one from the L'Hopital's rule, this is the limit of this quantity, right, log of 1 plus 1 over x over 1 over x, which is this one. So it is the same as e raised to power 1, or the e. Okay, so this limit actually determine the Euler number, or e raised to power 1. Okay. So on the same token, if you look at the last problem, okay, which is in terms of the limit as your x goes to 0 from the right of x raised to power x, actually this one is the same as e raised to power x log of x. Okay, so by the continuity, again you can pass your limit into the exponent. Okay, and you already know from this problem that this limit goes to what? Goes to 0. So it means that this one equals to e raised to power 0 or 1. So this one, okay, at the beginning you are not so sure whether it equals to 1 or not, because it is 0 raised to power 0, which is not defined in terms of mathematics. Okay, however, as you use the L'Hopital's rule, then you know that this one it is actually equals to 1. Okay, so we are going to stop this chapter 6 right here at this point. Okay, and we hope that you try to make yourself understand the derivative, as well as the application of all the derivatives that we give it to you, okay, over this chapter. So we'll see you on the last chapter of this course. Bye.